you remember why you started coding? You wanted to solve a problem, make a difference, change the world. And the world needed you. You made a difference. You helped solve those problems. But the challenges facing the world keep growing, multiplying, and it's getting more complex. Billions of people have joined the global economy, and billions more are on their way. While the volume and data continue to multiply exponentially, expectations have gone from hours to minutes, from seconds to instant. The chasm between what you are expected to do and what you can do can no longer be ignored. It's time you took back control. It's time for the next monumental shift to overcome these problems. But how will you solve the problems of today while meeting tomorrow's expectations? You can't use the solutions of the past to solve for the future. Thankfully, there's Redis, used in the most demanding applications and environments.
Ladies and gentlemen, please welcome co-founder and CEO of Redis Labs, Ofer Bengal.
Good morning, everyone, and welcome to RedisConf 19. We just celebrated the 10th anniversary of Redis, and what an amazing 10 years. So over this time, Redis became one of the most popular open source projects ever. And I would like to thank, first of all, the creator of Redis, Salvatore Sanfilippo, for developing such an amazing product. Salvatore. Secondly, I would like to thank the companies who sponsored Redis over the years, starting with VMware, later on Pivotal, and lately Redis Labs. But most of all, I would like to thank you, the community of Redis, for being such an amazing supporters of Redis over the years, fixing bugs, creating clients, and most of all, adopting Redis to your applications, use cases, and projects. So thanks very much. Let's recap quickly those 10 years. So the project started in early 2009 by Salvatore. Later this year, he presented the first data structures and capabilities. A year after, more data structures and capabilities. And then in January of 13, Redis Sentinel. April 15, Redis Cluster. June 15, Salvatore joined Redis Labs. July 17th, Redis Modules. In September 18, we crossed 1 billion pulls of Redis on Docker Hub. And then on October 18, we introduced streams. Now, the same basic guidelines which led the development of Redis from day one are still valid today. And these are, first of all, minimum number of code lines. I don't know if you know that, but today Redis has approximately 70,000 lines of code. This may seem high, but for a complex product as Redis, this is basically very, very low. Simple to use. Redis is very intuitive to use. extremely stable, well documented, and above all, always the fastest. This made Redis extremely popular among developers, and year after year, Redis is being voted the most loved database in Stack Overflow surveys. Moreover, Redis is ranked number 7 out of 350 databases by DB engines. But more importantly, if you look who is above Redis in this list, so you'll find only one new database, which is MongoDB, and all the rest are legacy databases which have been with us for decades. Only 6 months ago, we crossed 1 billion pools of Redis containers, and now, 6 months after, we are already at 1.5 billion. Isn't that impressive? I think it is, yeah. The world is becoming faster and faster, and so does information technology. Look at this quote here. Analysts estimate that in less than 10 years, more than 25% of data created will be real-time in nature. Redis is the optimal database to deal with this type of data. Modern applications need to respond instantaneously, and this is because the new breed of users do not have the patience to wait. They would like to click and get it, tap their phones and get it immediately. Redis is the only database that can process tens of millions of transactions per second, and all that with average latencies of less than 1 millisecond. So, ladies and gentlemen, welcome to the world of instant. Now, to hear what's next, what's coming up, and especially about Redis 6.0, I would like to call to the stage the creator of Redis, Salvatore Sanfilippo. Salvatore.
Thank you all. Thanks. Hi, everybody. Thanks for joining us here. So after 10 years, I think that, technology is strange because there is a big factor of fashion. So maybe Redis was good or maybe it was fashion. But probably if in 10 years, you cannot stay in the hype curve for 10 years, I mean. So at this point, I could put a bit aside the imposter syndrome and probably say that there is something good about Redis if for 10 years it was able to capture the favor of the community. Also, I am not the kind of person which is very constant. I mean, normally I would start something and after 1 year and a half, like, I don't want to do any more like this. But with Redis, it was different because of the community that created, built around the project naturally. Because I think that I had always a no bullshit communication basically rule. And people understood really what was Redis, what was the drive for simplicity, what was me continuously saying no, 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 no to everybody. You know, you can think maybe that this is an asshole. But there is a part of the community that instead understands that simplicity is a very, very important component of modern technology because we saw complexity. And we saw that complexity really fails in certain ways to bring good fruits. So there was to explore the other option in an extreme way. However, now there is to capture what was good in these 10 years and to continue to do it, because after so many years and with Redis growing in adoption, the temptation to ruin it and create a big ball of bloatware is very high. You know, it was consistently made in a simple way, but it's not obvious that we can continue in that way. So instead, there is to understand what are the values of Redis, what made it popular, and what made it popular despite Usually, it was just me and another person for 5 years, and now I have a larger community of contributors, but still the resources that went into Redis were extremely smaller compared to all the other databases. So probably there is something about this concept of trying to accomplish a lot with the minimum effort and complexity. And this is what allowed Redis basically to become big despite being small, you know. So how to take all these ideas and turn into actual future features, ways of doing things, and so forth. I think that Redis 6 is kind of the sum of all these ideas in different ways. Let's start with one of the most important things about Redis 6. Okay, I have... So, you know that Redis is very good to scale down, okay? You can just compile it, execute it without configuration, it works. You can compile it on a Raspberry Pi, and it works. However, of course, there are certain use cases that need to scale up. So in the past, I put a lot of efforts in order to create Redis cluster. Redis cluster took a lot of design time. Then it was complex to implement it. I implemented it the first time. It was terrible. And I re-implemented it, and it was good. It was better. And people started to use it. At the same time, other solutions for clustering Redis emerged. And unfortunately, for a long time, I had no bandwidth in order to give enough love to the project. For a lot of time, it was basically almost abandoned. Yeah, kind of supported, but never actively developed. And still, the community used the Redis cluster more and more and more and more. Basically, the community accepted it as the standard way in order to scale Redis. Now there are a lot of use cases solved by Redis cluster, and a lot of big users of Redis that are looking to jump into Redis cluster in order to solve partitioning, high availability. And Redis cluster design is very humble. The design is one that tells the user, I don't want to mask in the cluster a lot of complexity. I'm more happy to believe that you are not stupid, and I want to expose you the complexity. Because anyway, if I try to proxy queries, aggregate results, in the end, performances will not be great. Instead, I show you the trade-offs directly, and it's you that design the application in order to work within the limits of these trade-offs. So everybody's happy, the application is fast, no magic, hidden magic and stuff like that. Finally, something happened very important. I was ready 1 year ago to stop every other work to just focus on Redis cluster and do just that. But fortunately, Redis Labs hired a friend of mine, Fabio Nicotra, in order to work with me. He's also based in Catania, so we also work together physically, and it's a very nice setup. And thanks to that change, I was able to resume the work on Redis cluster, helped by Fabio, so we went faster. So the first thing that we did was, that he did actually, was to CLI. Do you remember that we had a Ruby script called Redis strip in order to manage the Redis cluster? This was implemented in Ruby, was slow, was too unstable, because if the Ruby Redis library will change, it will break Redis strip and so forth. So Fabio took Redis strip and ported it inside Redis CLI, the normal utility that we use to interact with Redis. And this was a good step forward, because it's a lot faster, it's more reliable, and finally there is somebody that incrementally adds features. Now we have, for example, a feature in order to take the backup of a whole cluster with a JSON file that describes the topology and the RDB file, so in case of disaster recovery, we can restore back and stuff like that. Then Fabio did another thing, that is the benchmark. Basically, nobody could tell how fast was a Redis cluster because there was no benchmark able to understand the Redis cluster protocol and connect with multiple instances to run a test. So Fabio did two things. One was to introduce threads in Redis benchmark, and now it's possible to launch the benchmark in cluster mode, so each thread will connect to a different master instance and will run basically the benchmark and collect the salt back. And you finally can see like you spin a small cluster and it processes like 3-4 millions of requests per second. It was obvious already. To people that knew Redis, it was obvious. But now we can at least show how easy is that, and that's good. And then the Redis benchmark was also threaded regardless of Redis cluster. You can now start the benchmark using multiple threads. However, there is one missing thing. I have a program, a schedule during the next 6 months in order to improve Redis cluster server side a lot with new features. But there was a very lucky spot, that is the client implementation. Unfortunately, to implement a solid Redis client is a lot of work. And to implement a solid Redis cluster client is more work. So we saw certain clients that were very good, certain that were very terrible, and another set of clients that simply lack any cluster support. What's the solution? The solution was to start a new project, that is the Redis cluster proxy project. So this is how the proxy works. So this is our Redis cluster. You basically have this proxy, which is multi-threaded by default. This is thread 1, thread 2, thread 3. And here there are clients that believe they are talking with a normal Redis instance. But for the multiple keys operation, that have the same limitations of the usual Redis cluster. You have to use key tags in order to put these keys nearby if you want to do an intersection, a set intersection between two keys. You have to use key tags in order to create affinity of these keys. And what the proxy does, this is the proxy, is to basically forward the query and reply back and so forth. In this way, now, users that want to scale with Redis and want to use Redis with clients that lack a good support for Redis cluster can use the proxy. The proxy project started like 2 weeks ago officially. We and Fabio get together and started to design it. And after 1 week, he returned with something working. I said, "Are you crazy?" And of course, it will take multiple iterations. But it's very interesting that Fabio completely got the Redis way of starting with a very small prototype that could do something, and then we built from that point. We create organically. More complexity is just the minimum as needed. And I want to show you how the proxy works. So basically, okay, here are the masters, and this is the proxy. This is the client. The client, here there are multiple threads. Let's zoom one thread, T. So we give a request like get. Each thread has a Redis cluster object. This is basically the representation of the Redis cluster topology in the mind of the proxy, and the connections to all the instances. So this object has all the connections using a high Redis, the C client library, to the different masters and replicas. Then we received this get, and this Redis cluster object has different queues. There is a queue for incoming requests. Then the request is transferred to the right instance. Then we get, once it's transferred, we move this request from here to the pending reply requests. The reply arrives. We take it. Here there is a client pointer, so a client request pointer. So we remember this is about this client that did this request. and we route it back to the client, and the reply will be transmitted back. So what's interesting is the following thing. We start with a single cluster, with a single Redis cluster object for thread. As long as clients connecting don't try to do any stateful operation like multi-exec, wait, or whatever, we use a shared object, a shared cluster representation. So we do multiplexing for free. As long as a client want to do complex things and send like multi, in order to send a Redis transaction, any stateful, basically, operation, we copy and write this object, we duplicate it, and assign a new one only for this client. So basically, each client will have, each client doing complex things will have its set of specific connections to the cluster. However, clients that do simple things, for example, in the caching use case, set and get, will be able to share a single connection without any added complexity, which is normally found in proxies that will implement multiplexing. And the license of this project will be AGPL, and it will be part of the Redis project, but living in a different repository in order to be more modular, because many people will not need the Redis cluster project proxy, so that's the idea. Okay, but why we believe that the Redis cluster is the way to go in order to scale? Well, because there are other options. For example, threading is one option. I have this machine with 32 cores. This is a CPU, no? Very nice CPU. What we believe is that having multiple processes with a shared nothing architecture eventually is the best way in order to scale, even because sooner or later you have to add new computers, right? So threading will solve this scalability here up to a given point, but will never solve to go cross-machine. So why to find two solutions? Instead, what this allows is that every Redis process handles a subset of memory with a smaller AOF file, and is probably also pinned to a given network interface, because with Redis it's very simple to have problems with scalability regarding to the network bandwidth. Often you are network bound, not CPU bound. So this is, we believe, a very, very scalable approach. And with Redis cluster proxy, we can mask this complexity under the proxy. However, the Redis project has a very long history of trying to grab the low-hanging fruit. So, there are certain subset of the community wants threading. A large subset of community instead appreciate a lot the simplicity of Redis, the reliability of Redis, and don't want threads. However, it's possible maybe to give something to the community that wants threading. They are not crazy. Look, it's just that they are using a lot of operations about multiple keys that must be in the same instance. They have legacy installations, don't want to scale. It's more complex. If you can live with a single instance, it's clear it's simpler. So those guys or girls are perfectly reasonable to wanting, basically, the ability to scale a bit with a single instance. However, threading is very complex. Once you add threading in a project like Redis, every new feature will have an entry barrier, because you have to fight with threads. However, is it possible that there exists a very low-hanging fruit for threading on Redis? Well, apparently, yes. So 1.5 years ago, I started this project to do the following. Basically, Redis is single-threaded. It gets the queries from the network, from the clients. Then it basically processes this with data structures, and then we have to send the queries the replies to the client. However, because Redis is sequential, actually these are our reads. Then we process the data structures, and then those are our writes. However, what about just taking this stage when we write and make just that threaded? So we have a single threaded timeline. We fan out just for writing. Why I want to fan out just for writing? Because if you profile Redis or any other networked server, you find that like 70% of the time that the process spends is inside the kernel in order to send write, in order to send data back to the client. System calls are extremely expensive, but the write system call is terrible. It's like a killer. So I tried this process, this design. So basically, here inside the event loop, we receive all the reads and so forth. We execute the commands later. There is a function in order to write one after the other all the replies. Instead, here what happens is that I have multiple spinning threads, and I distribute these writes to the threads. They write, and then the main Redis process waits for the writes to complete, and it becomes again single-threaded and continuous. So here we no longer have the complexity, right? Because threading is isolated in a very small spot. However, there was a problem. When I implemented this 1.5 years ago, all the time that I was winning thanks to that design, I was losing because of the synchronization between threads. Because of mutex and because the thread needs to sleep if there is no work to do, so it's the kernel scheduler that must be stop the process, resume the process. This doesn't work. So I was almost to give up. Then a few weeks ago, I was in, you know those days that you completely don't want to work, absolutely zero? Like I get up and I say, what to do today? I hit the gym. Then I was driving to the office and I say, no, I will return home, and went with my wife like to, don't know, in the town. Then I returned home and said, oh my God, you know, I have a philosophy. Every day I have to do at least a small step in order to bring Redis forward. Not getting like crazy with work, but every day I want to do a bit. And instead, the morning passed nothing completely. So I said, okay, I will just after lunch stay 5 minutes and I will get to the office. And instead I fell asleep, and it was 5 p.m. when I get up. So basically I went to the office, and there was a friend of mine. Do you want to grab an ice cream? Okay. We went to grab this ice cream, and I returned, and it was 7 p.m. Now Redis Labs, by the way, will fire me, but it happens. So at 7 p.m. I arrived to the office. I said, I burn a day doing nothing. I have to do something good. Otherwise, I will not go home today. So I said, okay, let's resume this threaded I/O branch. What can I do in order to make it working? And I said, let's try with C11 and atomic vars to use spin locks, so that basically all the threads are in a busy loop waiting for writes. The main thread will signal that there is new data in the queues, just setting an atomic variable. The threads will start processing. The main thread will spin lock, waiting for the process to end. And once I did this model, immediately things started to work very well. So I have here a live demo that will never work. Okay, basically, this is Redis. Sorry, I am on EC2 instance that it's very slow, but Don't use your cellular phone with the Wi-Fi network. Okay, this is basically the branch. It's the normal Redis server, okay, but I wrote IO threads 8. So let's remove this IO threads thing. So I'm not using IO threading, and I start the benchmark, like, for example, with 8 threads, and each thread will use 150 clients and so forth. I execute this benchmark. It's real time, right? But the network is so slow that you see it barely updating at all. So, okay, the number is basically more or less 200, 180 K operations per second. Now, if we return back here, and this time we try to use IO threading, too slow. Okay, let's try again. Okay, as you can see, the performance improvement is incredible. If you think that we just threaded this single write thing, and the cool thing is that I can do it in the read side as well. Or even in the part that parses the protocol, because I will do the same thing. Basically, when I am in the event loop and the readable handler fires, instead of really doing the read, I just put the client in the read queue. And when I am outside of the event loop, I have this queue with all the clients that have pending reads. And I, again, fan out, use the threads, and bring again back everything a single thread and then continue. So this is, very promising in general. So Redis 6 basically is going to be a lot more scalable because of the proxy, because of the improvements to Redis cluster, but also more scalable from the point of view of the operations. Because now we have a very important feature which is called Redis ACLs. I want to show you the gist of this feature, this time locally, so we are much faster. So, normally Redis had no concept of users. You just connect, you can have an optional password, and that's it. There is no level of... in some way, there were certain folks that asked for security. For example, very big enterprise use cases want to have users and all these kind of things. However, to bring inside Redis ACLs, in my opinion, this was not enough. There was another very important point, that ACLs, access control, gives you operational safety. Basically, sometimes you have a very important Redis installation, and you download some library from internet. For example, Rescue or Sidekick, one of these libraries in order to handle delayed jobs. And you have no idea what's inside the library unless you want to do a code review of every bit of software you download from the internet. It is possible, however, with ACLs to just say, this library will be able to call these commands and with these keys, and nothing more, if it wants to do more. So you can see that ACLs are not just a security feature, are also an operational safety feature. And the way it works is very simple. So I stop the server and restart the server, so it's completely empty. And I can create immediately a user called Untitled on, which means it's active with a given password. And I want it to be able to access all keys. And I add all the commands of Redis to the list of, or to the white list of commands that this user can execute. However, I remove the debug command. Now the out command takes 2 arguments, username and password. So it's an extension of the original argument. It's still completely backward compatible. If you want, you can use 1 argument, and it will default to the default user. Now I can like ping, set, foo bar, but if I call a very dangerous command, it will tell me that I have not the permissions in order to run this command. I believe that this is part of the scalability of Redis that will bring with Redis 6, because it was completely sensible for 10 years to ignore this kind of stuff, because we had more important things to do. But at this point, it's very important to have some of these features. And what's cool about this feature is that it has completely no cost from the point of view of the execution time, because what we do is the following, which is basically we have a client, and the client has associated a bitmap. Every single bit represents a command, and if a command is allowed, basically this bit is set, and if a command is not allowed, the bit is not set. So basically checking at runtime if a connection has or has not the permission to execute a given command is immediate, very fast. So there is no performance penalty about that. The cool thing is that you can also set subcommands, ACLs, and glob patterns for keys. So you want to, for example, a given user to be able just to access the keys that are object asterisk or something like that. In that case, you pay an additional penalty, very small. But if you don't use such feature, we flag the user with all keys, and this check is completely skipped. And another scalability thing which is very important is the new Expire algorithm that Redis 6 will have. Right now, what happens is that when Redis wants to expire one key, it has to perform basically a lot of samples in the key space to check if a given key is expired or not. And instead, we are going to use a data structure that will sort the keys by the expire time. So every expire cycle, we can just go and it will work much faster. OK, so in general, I think that Redis 6 will bring a bit of stability, maturity in the project. And the release date should be probably October of this year. And so, well, thank you for joining, and I hope you will enjoy the next talks. If you want to talk with me about these features, just stop me, and we can talk. Thanks.
Ladies and gentlemen, please welcome the CMO of Redis Labs, Manish Gupta.
Salvatore. Thank you. Thank you, Salvatore. Well, welcome to the 5th annual RedisConf. I want to commend you all for braving the weather. How many of you are wet? You know, we picked the themes very carefully to reflect what's happening in the marketplace. Last year, we picked the theme everywhere. Redis truly has been used in many use cases, much more than caching as a true primary database across any industry that you can think about. What we found over the last 12 plus months since the last RedisConf was the use cases that Redis was trying to solve or is able to solve became so extreme and difficult for any other database to solve, we felt like we were starting to create a new environment, a new experience. It's also the experience that we as users expect and demand of our applications, and that's the instant experience, hence the theme instant. You know, last year we had about 1,200 people. We're expecting about 1,500 that started yesterday, today, and tomorrow. That's about 25% growth. So thank you all for continuing to grow and foster the community. One new thing we've added this year is live streaming. So in addition to the folks that are here, we expect thousands of folks around the world to participate in this event and to be able to share and get the knowledge that you'll see over the next 2 days while you're here. We have about 75 speakers, and very interestingly, this is across 6 tracks, they are from 13 countries. We have speakers from Kenya, from Costa Rica for the first time. So I think the power and virality of Redis is not just in the people that are using it, but the people that are actually propagating the message, that are propagating the technology around the world. And that's just, it's really heartening for us to see that. A very, very important thing. You know, yes, we develop a lot of applications, and as more of the workloads are moving to the cloud, participation of all the clouds is very important. So for the first time, we have all of the major cloud platforms here in one way or the other, whether it's part of the keynotes or doing sessions. And you can see Google, Azure, AWS, and even Oracle is here. I encourage you to stop by their booth. They may have an interesting Redis announcement if you talk to them. Pivotal's here, Alibaba is here, Red Hat's here. So we've got almost every platform you can think about that's supporting, driving, and growing the deployment of Redis. And finally, I wanted to thank the sponsors, without which this is not possible. So in addition to Redis Labs, there are many other companies, so I want to thank everybody. With this, it's my pleasure to bring on stage back Ofer Bengal, our founder and CEO, to talk about some great announcements.
Good morning again. So we at Redis Labs are building Redis to be a multi-model database, and we do it by building a dedicated engine for each of the data models. So on top of the native data structures of Redis, we already have today search, streams, probabilistic, document, and graph. More importantly, we build each one of those data models to be the fastest in the industry. So with native Redis, we are 150 times faster than Cassandra. With search, we are 5 times faster than Elastic. With graph, we are 250 times faster than Neo4j. And with streams, we are 500 times faster than Kafka. But we do not stop here. So what's next? Redis and time series. So time series is gradually becoming one of the fastest growing segments in the database industry, as you can see here, according to DB Engines. And no wonder, because there are many use cases for time series database, for cutting-edge applications such as autonomous cars, connected cars, smart homes, DevOps tools for monitoring servers, networks, devices, et cetera, et cetera. When it comes to Redis, today we have 2 ways of processing time series data. The first one is combining sorted sets with hashes, and the second one is with streams. Both have many gaps in the areas of compaction, aggregation, labeling, retention rules, enhanced queries, and compression. And we wanted to fill all these gaps. So today, I'm very happy to announce Redis Time Series. Redis Time Series is a new module which was developed in Redis Labs. And to talk more about it, I would like to invite to the stage the creator of Redis Time Series, Danny Musayev. Danny.
In Redis Labs, we wanted to create a Redis native data structure for time series. For that, we needed several specific features that we must have in a production-ready time series database. Downsampling is a big feature in time series databases where you want to save long-term data, but still keep it, but still have small footprint in the memory. By having multiple downsampling rules on a key, you can have any aggregation that you want on a key to be automatically downsampled to a different key. Thus, you can have lower footprint on your memory size and still have long-term data. Having the data in memory, you still want to query it. Range query was not enough for us. We also wanted to have some kind of aggregated queries. So you can pick whatever aggregated function that you want and query the data. So we added that. In addition to that, we also added labeling and secondary index on those labels. So now we can also query the data according to the labels and have multi-key response according to your secondary index. On top of that, each key can have its own retention rules, and you can pick how much time you want to keep the data. Thus, you can make your memory footprint lower. In addition to the regular time series use case, we also thought about new use case that you can use time series with. And a lot of folks use Redis today for counting. If you use incur by or decur by, you can use it with Redis time series and also have the history of your counters. You can query the latest result, the latest value of your key, but you can also query the history and see your counters over time. Tomorrow we're going to talk a bit later about more connectors and industry standard tools that you use with time series, and now we can use that with Redis time series. And soon we're going to release a new version with compression built in. So to wrap it up, what we have is a Redis native data structure for time series that each key contains several chunks. Each chunk contains several samples. Those samples are indexed with the enhanced, with radix tree, which is comes from the robust architecture of streams inside Redis. And if you query the data, it basically goes through the radix tree before before we get the actual timestamps. And also the aggregated downsampling rules save the data in different keys, so you can query whatever key you want and have the data as fast as you want it. We also started to work on a benchmark. As you can see from the results, we are faster between 4x and 30x from other industry standard databases. And in the coming weeks, we're going to release the code and the results, the full results of the benchmark. Okay, thank you.
Thanks very much, Danny. So Redis time series will be discussed in more details tomorrow at 1:30 at Alcatraz. So what's next? So Redis and artificial intelligence. So today we have several experimental modules that deal with artificial intelligence. The first one is Redis ML for serving machine learning models which were trained with other platforms. The second one is Redis TF for serving TensorFlow models. And the last one is Neural Redis for training and serving basic DL models. But we always thought that we need a production-ready, cutting-edge module that can serve effectively ML-DL models which were trained by leading AI platforms. So today, I'm very proud to announce Redis AI. Redis AI is a new module which was jointly developed by TensorWorks and Redis Labs. And to talk more about it, I would like to invite to the stage the CEO of TensorWorks, Luca Antiga. Luca, please.
Thank you, Ofer. Hi, so TensorWorks is busy creating the tools for the new wave of data-defined software development. And Redis AI is the first example of that. Putting AI in production is one of the challenges of DevOps today. You have new workflows, new compute that needs to be served everywhere, from large scale to small scale, close to the data or on the cloud. That was maybe developed with different frameworks. TensorFlow, PyTorch are the leading ones, but there's a number of others. So you don't want your decisions on what framework to use to interact with your decision on how you deploy those models. You want to keep your data with computation because your stack has to be as short as possible to be cost effective and operationally easy to manage. And of course, we want to leverage infrastructure that has been built since 10 years, for example, all the operations around Redis and Redis itself. So that's what we looked for when we decided to go ahead with this project together with Redis Labs. So we took Redis and we added a new data type to it, which is a tensor. For those of you who are accustomed with deep learning, tensor is a multidimensional array that contains numbers in a very efficient representation in many dimensions and in the indexing space. So now you can set, with Redis AI, you can set a tensor to a key and get the tensor back. And then you can set a model that was developed with PyTorch or TensorFlow, or in a short time with basically any other framework, because there will be support for Onyx, which is an interoperability standard in the deep learning space. And Onyx also supports traditional machine learning models with Onyx ML, so you will be also able to set a random forest model or a support vector machine inside Redis and run it on the CPU or GPU or multiple GPUs, all without having data or go out of Redis to do that. And not only that, PyTorch supports an interpreter of tensor operations. So it's called script in PyTorch. And we took script, we put script inside of Redis, and now you can set a text file, like text, a field to a key, tell Redis it's a script, and then run that script against other tensors in memory on the GPU. So you can do GPU computing without actually touching TensorFlow and PyTorch directly in Redis. And you can do it at scale with a master replication or cluster. So for example, use case, let's see why it is important to get an answer, but also to be able to keep your data on Redis while you're running your models. Say you have this nice cluster of Redis instances, and you have a chatbot that you want to deploy. Chatbots nowadays are done in many ways. One of them is a sec-to-sec model, which means you take a sentence, you feed a recurrent network with the sentence. The recurrent network, word by word, builds a vector of numbers that represents the content of the sentence, the semantic content of the sentence, and then a decoder. After that, it's a network that is more or less symmetric with the ones that encoded the sentence into numbers, takes those numbers and encodes a sentence as a response. So you have an input, an output, and a state, and that state represents the state of your conversation. So you can now convert your words into numbers and then send them to Redis. You get an answer, but you also get a state, which is your state of a conversation, which is not much different than a state from an interaction with a web service. It's the same concept. And now Redis can store the state within the instance, but also it can distribute it to the replicas, for example. And what happens is that Redis instance goes down. Well, Sentinel will elect a new one containing the state of a conversation, so your conversation can continue. And this kind of clarifies why it is important that DevOps dealing with AI leverages on technology like Redis, as we tried to do. Now, let me show you a little demo, hoping that everything works. We took a very nice tutorial from PyTorch, just so you can replicate it. It's in the PyTorch website. And built something that's deployed on Redis with a chatbot. I don't know how the chatbot will behave. Well, I kind of figure out. I'll try it before, but we'll see. So this is how you start Redis with the Redis AI module, just load module. At this point, Redis can talk tensors. So if you fire the Redis CLI, you can set a tensor this way. AI tensor set, foo is the key. Then the type of the numerical representation of the tensor, in this case it's float 32-bit. The shape of the tensor, 2x2 matrix in this case. And then you can provide either a blob, a binary blob, or just values in the form of numbers. So now we have a 2x2 matrix containing 1, 2, 3, 4. And you can get the values. So this is a very easy way of dealing with tensors. Now, I have a very tiny application here serving this chatbot. This was developed by Sharon Thomas, who's working with us at TensorWork. And if I'm contacting the chatbot, nothing happens because Redis doesn't have any network in it. So let me install the encoder on the CPU, because this computer doesn't have an NVIDIA GPU in it, and the decoder. Okay, so let's say what happens.
Hi.
Wow, what is that? How are you today?
Fine.
Wow, nice, great.
Yeah.
Yeah, okay. That's a very engaging conversation, but we trained the model a bit more, and we have an encoder B and a decoder B that we want to install. Now, at the same key, you have another network. Let's see what happens. Hi, Redis.
Hi, Roses.
Oh, this one is smart. So, how are you today?
Okay, I'll have a walk.
Okay. Where to?
Out of here.
Okay. I think I'm done. Thank you.
Thanks much, Luca. So it is also very important to note that Redis AI runs where the data lives. And to demonstrate the importance of that, I would like to show you the following example. So let's look at a credit card transaction scoring. We are all familiar with that. When we go to any point of sale, we give our credit card, we enter our PIN, and then we need to wait for the verdict. Yes or no, right? Now, what happens under the hood is that the transaction goes to an app server, and the app server uses two resources. The first one is a database which hosts all the profiles, users' profiles, merchants' profiles, geographic profiles, et cetera, et cetera. And then there is the AI serving layer, which is basically the decision algorithm. So typically, the app server sends a request to the database, bring me the applicable profiles, and then the app server vectorizes the profiles and send them to the AI server for the decision engine to come back with the verdict, yes or no. Now, all this can easily take 200 milliseconds. And this does not include the round trip over the internet from the point of sale to the data center where the app servers reside. This is how we do it today. Now, let's see how you can do that, the same thing with Redis AI. So here, basically, all the users, merchants, geo profiles, et cetera, will be hosted in Redis, and the decision algorithm will be in Redis AI. With a single API call, you basically approach Redis, give me the result, and you get the result, yes or no. This will take approximately 15, even less milliseconds, which is 15 times faster than any other system of today. Isn't it impressive? I think it is. So with this, we are going to discuss more Redis AI today, later on at 3 p.m. at Alameda. I would like now, for the next subject, which is a new approach for multimodal database, to call to the stage the CTO of Redis Labs and my co-founder, Iftach Schulman. Please.
Thank you, Ryan. Hi, everyone. So, you know, part of you may think, why do you need multimodal? There is a very big conversation whether polyglot persistence is better than multimodal. And AWS is one example of approach for managing databases. With AWS, for every data model, you practically have a separated database. This is very good if you use one or two databases for your use case. But if you try to use more, then you first need to copy your data across all these databases. Then each of these databases has its own clustering, sharding, replication, data persistent, backup techniques. Now, with the AWS example,
Some of these services provide to you as an instant base. You can select the instance, but some of them are even more advanced and are serverless. You don't see the instances, you don't see the infrastructure. And for each of them, you need to have a separate connector in the client, and each of them carries different pricing mechanism. But practically, for this discussion, what is more important, if you want to do some operations across these data services, you need to get out of the database, develop a Lambda function that takes data from one data service and bring it to other data service. And this operation is just slow, something between 50 to 100 millisecond latency for a single database request. And you all know that for a single application request, you usually have multiple database requests. So the entire database operation can be approximately 1 second. So Azure took a different approach, and they developed what is called multi-model database with Azure Cosmos. Now, it solves the problem of managing multiple databases in your data center, because everything is one database. But once you logged into a model with Azure, it's usually very hard to approach other modules. And then you need to use the same techniques that you use with AWS, but in this time with Azure Functions, which runs outside the database. And again, it is between 50 to 100 millisecond latency. And a question to be asked is whether Redis can do all that at sub-millisecond latency. And if I'm asking the question, the answer is, of course, yes. In this session, we will show you 3 techniques how we do it in Redis. The first one is called direct intermodal communication. So we just created a new version of Redis that allows you, or allows modules actually, to auto-discover and use other modules in the same database. And the first thing that comes to our mind is whether we can search in graph. So today, we would like to announce that Redis Graph is using Redis Search for graph traversal and better queries. And for that, I would like to call to the stage Roy Lipman, who is the leader and the creator of Redis Graph, together with Kyle Davis, who is the head of developer advocacy at Redis Lab. Roy, Kyle.
Thank you, Iftach. Hi, everyone. It's great to be here. So, at Redis Labs, we have different teams working on different modules. And those modules, up until recently, were isolated from one another. And so, when we started thinking about extending Redis Graph search capabilities, we knew we wanted to use Redis Search. And now, once those 2 modules are integrated together, Redis Graph can perform full text search. This includes fuzzy matching and prefix search. Consider, oh, I've skipped my slide.
This is not you, this is...
Oh, can we change back to the slides, please? Great, thank you. So consider this slide, this query for an example. It searches for every faculty member with the title PhD, but it will also make sure that the faculty member's name starts with Tim. So you can expect Tim, Timothy, and Timur to show up. From there, we can follow up with graph traversal. To demonstrate this new capability, I would like to turn it over to Kyle.
Thanks, Roy. So if we go to the demo now, we built a demo where we took the animal kingdom. You have mammals they have genuses inside of that and species and that sort of thing. And we put it and we connected it through a graph. And we're going to do a search on that. So on the left side, we're going to do a little search here, live demo. Let's see how this works. So I'm going to type cat. Now, you can see here, these are the calls at the bottom that are being issued, right? So I'm doing graph queries, and I'm searching on the species here for cat. If I look here, there's a heck of a lot of these, so let's do something more. Let's look for house. Okay, there's a couple of these and a pet, right? So we can see here, this is a house cat, and so we have this one. I'm going to select that by just clicking on it. And then I'm gonna look over here for maybe like a striped cat. So cat. Okay, there's a couple of those, looks like. I'm gonna click on those. And then what we're gonna see here, I've done this graph query, if you notice it here. You can see that they're related both in the family of feline, basically. Now, I'm gonna go in and search for something else. So let's look for an animal that's very wise, probably a human, right? So we have this. This is a human. And as you can see, this striped cat and humans are only related as mammals. And we can do all sorts of fun stuff. But you can see here, this is the actual graph query that's being issued. And I'm never doing any type of search. This is all occurring inside of graph. So if we want to do something else, we can look for bottlenose. And we'll probably get like dolphins. And we can see that they're mammals. And I could look for a whale here. And they're both in this family. So they're doing graph traversals on top of the nodes, and we're doing full text search there. So that kind of demonstrates the power of that. So thanks.
Thank you, Kyle. This is very cool. There are 2 sessions today at 2 p.m. at Alcatraz and tomorrow at 2 p.m. at Alameda about Redis Graph and how you can better use it also with search. The second technique that I would like to mention today is how we use a single data copy between the cores of Redis and the modules. So for those of you who are familiar with modules, it was developed from day one. The capability for module to directly access the data structures that include in the core. So for all of you here that know computer science, this is first, you have less mem copies. Second, you put just less copies of your data, so it is more efficient. But last but not least, it helps you to solve very complicated problem. And I would like to give you an example of just one of them. So last year, we presented a very innovative approach of doing active-active with Redis based on CRDT. We mentioned that with this approach, you can continue serving requests at a sub-millisecond latency because CRDT has no consensus. It's consensus-free. You don't need a consensus protocol between the replicas. And we also mentioned that CRDT uses a dedicated conflict resolution algorithm for each data structure. Now take this approach that modules can now share data structure. It will be nice if modules can natively share this data structure and use them to run active-active configuration across the world. So today, we would like to announce that Redis Search is available in active-active configuration. And let me show you how it works. This is just a demo slides of demo. Let's assume that someone is indexing Jim in the US. Redis Search will take Jim, will translate it to hashes. Hashes are already being replicated with CRDT across the replicas. Once it is arrived to the destinations, Redis Search will be notified, will re-index Jims. So next time someone is accessing for Jim in Europe, it will get the exact same documents that was indexed in the US. And this is just one of the things that we can do with the fact that we share the same data structures across the cores and the modules. There is a very interesting session tomorrow at 3 p.m. at Razer about how you run Redis Search with active-active deployment. The third technique, which I think is the most interesting, is to allow in-database multi-model programmability inside Redis. And today, we would like to announce Redis Gears. I like this name. It's a very nice name. What is Redis Gears? Redis Gear is a serverless engine for multi-model operation in Redis. It is implemented as a module that runs inside Redis. It supports event-driven operations. So for instance, you can listen to a stream and do something, or transaction-based operation. You can get a user transaction and execute it with Gears. Today, it supports Python, but later on, it will support other languages. Redis Gears is extremely fast. It is built over a distributed cluster architecture written in C. It has communication engine, coordinator, and map producers. And it supports all the languages with C API. So I mentioned earlier Python, but soon Java and Scala. But the infrastructure itself is written in C. Let me give you just a few examples of what you can do with gear today. So let's assume that you want to build a gear that listens to a stream and count how many messages arrived to a stream in a time series database. You can do it with just a simple 3-line of Python code. The first create the pipe. The second create the execution. That means it increases the counter whenever a new message arrives to the stream, as long as you're in the boundary of 1 second. And then it registers all this to a specific stream. This is just one example. Another interesting example that I guess many of you would like to use. You have data already in Redis, and you want to make it with a few clicks of a button, a multimodal database. You want to index it, and you want to make relation between your objects using Redis graph. So let's take this example for a second. We map all the cities in California to hashes inside Redis. And they have just a few properties, like the population, the size, and the most popular DB used by these cities. So you load a search with a gear engines that will immediately index your data. So next time someone is asking for popular DB equal Redis, San Francisco will pop up. And then you load a graph modules with a gear function associated to it, and then you create a relation between all the cities where Redis is the most popular database. Isn't it amazing? Gears. And the last example is something that we showed last year. It's a bit complex example. You got a Twitter fire hose, and you want to do 3 things. You want to count the word, you want to do index and search, and you want to create a social graph out of it. So last year, we showed how you can do it with the existing polyglot persistence of AWS. Of course, you will have to use something like 5 data services, 7 Lambda functions, or 6 Lambda functions, 5 connectors, and something like 7 network hops. We talked about the fact that this is complex, expensive, and slow. And we showed how you can do everything with Redis. But last year, we did it with a proprietary code. Today, we are going to show you how we do it with Gear. And for that, I would like to call Kyle Davis again to show you a very nice demo how Gears works in action.
All right. If we can go ahead and switch over. And I'm going to resize a few things. OK, so I want to show you a small example. This is what we had last year. I showed you this. All these boxes represented different things that were connected together by streams. And we're doing all the things that Div talked about. And we were challenged to then show something a little bit different this year. We want to show something how we replaced the core of this that had many different applications all connected by streams together with gears. So what we did is we moved over to this model. And in this model, what we have is the Twitter API going through, being put in as a stream. And then what happens then is Gears actually does all the processing at the database level. And then all we have to do is a server. So you can see this stuff going on at the bottom. We're going through and we're indexing a particularly interesting keyword on Twitter. And I'll show you what we can do here. So let's go ahead and take a look at, and if you notice, we're doing all these Z ads, Z increby, FT ads, and all this stuff. And this is never actually touching my client code or my server code. This is all happening there. So let's go ahead and do word cloud. And so we're going to see here, it's a live demo, some live stuff. So I'm apologizing if it is really not very nice things being said. But you can see here, this is going through, and it's using Z increby to count all these things together. It's pretty interesting, but not anything to do with any of the advanced features of Redis. It's just the normal stuff. So let's go ahead and we'll switch over to search. And in this case, we're going to be able to search all these tweets that are coming by so fast at the bottom here. So I'm going to go ahead and type in something simple, CNN. OK, there's lots of stuff here. You can type in let's say here, Mueller. Okay, so we're getting lots of stuff there. And we're doing full text search on all this. So this is all coming into the database really easily. And we're using Redis search on top of that. So that's interesting. Let's also take a look at how we can look at graph. Like how are these tweets connected and people mentioning each other. So I'm going to go over to my graph engine. And I'm going to render everything we have here. So we can see the connected graph of all the tweets coming through this. And this is really interesting because before we had to have all these things connected together, that we're doing this at the, writing some code somewhere else, but now it all occurs inside of Redis. It's faster, it's easier to build. My original demo last year was 700 lines of code. With Gears, I went down to 200 lines of code. So we can go in and take a look at how things are related. If I type CNN, we can see, let's zoom in a little bit, all the ones related to that. How are CNN and MSNBC connected? We'll type a search here. They don't have any NBC. We can see that they are connected, and I could go in and look at all the different ones here. So this is doing live graph queries on this data. So as it comes in, it's instantly indexed. So you can see the power of Gears. It simplifies your code, it makes it faster, and it really simplifies the architecture entirely, and all at the database level. So thanks.
As always, Kyle, very nice demo. Now that we have gear in place, let's review the Redis programmability options. So you all know that if you want to program a simple code, a simple core of Redis, you can use Lua for that. But if Lua is not enough, you can extend the Redis capabilities by adding modules or writing your own existing modules. Some of the modules that we have today also can receive a mini module inside them. For instance, you can do custom search with search, or you can add script to AI. And Redis Gears comes to solve a different problem. If you want to interact everything together in a fast fashion inside Redis, you should use Redis Gear. And for that, practically, I think we solve all the programmability problems of a database. So there are very interesting sessions today that you must go and see. One of them describes how you do from key value to multimodal at 1 p.m. at Alcatraz by Guy Corland. And an hour later, Meir Sperling, who is the creator of Gear, will explain the internal and will provide some use cases. And to sum it up, I would like to call again to the stage Ofer.
So let's recap what we had this morning. So we announced 2 new modules. The first one was Redis Time Series, which is, to remind you, 31 times faster than any time series database available today. The second one was Redis AI for serving complex machine learning, deep learning models created by leading AI platforms. We are still benchmarking it, but I can tell you that it will be even better in terms of, what you have in the market today, way, way faster. Then we talked about direct intermodal communication, where a single module can auto-discover and use another module. And we took the example of graph using search. Later on, we talked about how modules can share the same data structures, and by that, having a single database, a single data set copy with a multi-model functionality. And then we finally announced Redis Gears for enabling programming operations between modules. With that, we have today a very powerful database, which on top of the native Redis data structures have search, streams, probabilistic, AI, time series, document, and graph. And everything is glued by Gears. Now, the most important thing is that even with all that functionality, we were able to keep the performance of Redis as in core Redis, which is under 1 millisecond latency on average. I would like to conclude this session by comparing Redis multi-model functionality with other technologies in the market, such as Polyglot and multimodal of other databases, and to stress that Redis is the only multimodal database that can feature direct inter-model communications, single dataset copy, in-database multimodal programmability, and all that boils down to an amazing performance of less than 1 millisecond under any load. So, as I said before, welcome again to the world of instant. Thank you very much. Now, the evolution of Redis was always linked to the evolution of the cloud. And as we all know, the cloud is basically leading digital transformation nowadays. Today, we have a very special guest to talk about all that. And ladies and gentlemen, it is my honor to welcome the CEO of Google Cloud, Mr. Thomas Kurian. Hey, Thomas. Nice. How are you? Please have a seat. So first of all, thank you very, very much for coming. It's a great honor to have you here.
Thank you.
And I'd like to start with a personal question. So you have been a technological leader at Oracle for many, many years. And the decision to move to become the CEO of Google Cloud probably was not a very easy one. So what were the drivers for making such a decision to move to Google?
No, I left Oracle last September after working there for 22 years. I told my wife and son I was going to take 6 months off. I didn't know anybody at Google. In fact, I knew only literally one person. So how do you end up at another company 2 months later instead of 6 months later? It's a question my wife is still thinking about. It must be very persuasive. I think the reason was that as I talked about 100 customers. And the general thing I heard from both customers and partners is really amazing technology needs to become more of an enterprise company, needs to have a bigger sales organization, make the technology easier to adopt, and work better with partners. And so I said, well, maybe worth a shot to help Google and all of the technology it has to bring it to customers to help them every day.
Now, Google is known for being a massive player in whatever they do.
Yes.
How do you plan to differentiate the Google Cloud from other clouds and have it take its fair share of the cloud infrastructure market?
It's a great question. You know, when we look at, we at Google, our vision for cloud is to provide 3 types of solutions to customers who want to go through this digital transformation. First is what's our vision for infrastructure. Second is what's our vision for platform. And third is what's our vision for specific industries. So in infrastructure, the problem that we're solving and we're very focused on solving is the ability to enable a developer to write an application once and a workload once. And they can choose to deploy it in their data center. They have the ability to move it to Google or to any other cloud. And they don't have to change a single line of code. They don't have to change a single way that they configure security. They don't have to change a single way they do operational management. And to us, that enables this ability to operate multiple clouds no more than the cost of operating one. And we think there's enormous interest from customers to enable this because it allows them to train their people on one set of technologies and one way of doing this and have it work across different cloud providers. That's our vision for infrastructure. For platform, you know, we are providing 5 capabilities. One is to help people manage data at scale. Second is to build apps, applications. Third is to do analysis and decision support. Fourth is what we're doing with AI and machine learning. And fifth, what we're doing with collaboration. But the most important element of our platform that we feel is that customers need to have a platform where it's not just about the cloud provider's technology, but also partner solutions that they can depend on. And so I know we've been working together with your team to make Redis a first-class citizen in GCP. And we think partly it's because we share, and we'll talk a little bit more, your vision for this multi-model database. But it's also because we see that giving customers choice on the platform, our view is that the platform provider that succeeds needs to share its success with all the partner solutions that are available on top of it. And then the third thing is we're taking lots of Google's innovations and applying it to solving specific problems for specific industries, digital healthcare, digital media, digital retail. And we've got enormous capability from Google that's being built to deliver unique solutions to industries. So that's a lot of what we're trying to do, and a lot of it, our focus is making it easily accessible to the developer community everywhere in the world.
Good luck with that. Not an easy fight.
Yeah.
You have been a product leader in the database market for many, many years.
Yes.
Now, this market is undergoing significant changes recently.
Yes.
What is your vision that has developed and evolved over the years for this market? How do you see this market, or where do you see this market going?
So if I can give you an analogy, if you looked at structured data in 1970, and if you looked at this polyglot database thing you were talking about just now, it looked awfully similar to that, right? There were, none of you probably remember, unfortunately I'm old enough to remember, but they were hierarchical databases, and the way that you stored and managed that data was very tied to one model. So if you did something like VSAM, it was strictly hierarchical. And then relational technology came along, and the fundamental advance that relational databases made was the way you stored data and the way you accessed it were decoupled, because you could do ad hoc query separately from how you persisted the data. Now, if you fast forward 20 years, the variety of different kinds of data has grown enormously. It's no longer structured data. It's graph-oriented data, time series-oriented data, unstructured data that people want to make semi-structured and add structure to it, like text. But the fundamental principle that I think will eventually win is separating how you store data in one way, but making it accessible in multiple ways. And I think when I look at what you're doing with multi-model, the example that you showed, let's take a simple example. I want to find all the scientists who work together in a department, which is a graph, but organized by year, which is time. I think you would all agree it doesn't make sense to organize it by time and not make it available as a graph, or vice versa, organize it as a graph and don't make it available by time. And so I think there's been a lot, it's sort of the immaturity, if you will, of database technology in managing new things has led to this, you need 45 specialized databases. When in fact, similar to relational, as the database technology matures, you will find you want the ability to store only one copy of the data, particularly if it's changing quickly. You don't want to have multiple copies. They'll get out of sync. And then on top of that, you want to provide different access methods to it. And we share that vision with what your team was showing just now.
That's great, because all this thing is yet a bit controversial. There are people who are for polyglot, there are people who are for multimodal. It's very encouraging.
Yes.
So, developers are voting year after year for Redis as the most loved database.
Yes.
Do you love Redis?
I used it.
Just kidding.
I used it. I actually used it for the first time in February 2016.
Really?
Yes, long time ago. We were building an internal application at my company, and somebody said, why don't you try it? So I tried it. And I was very, very impressed by the response time. I mean, it's really, there's certain things that once you get from a certain factor of response time down, by 10x, the kind of thing you can do is vastly different than if it was just improving 10%. And so we actually used it a long time before you realized I was probably using it.
Very interesting. Now, at Google Cloud, you already have a Redis service, which is a memory store.
Yes.
What is your perspective of Redis as a technology in general, and specifically, how do you see large enterprises using it in mission-critical real-time use cases?
My sense is that lots of large customers have 3 basic problems. And Redis does a great job solving it. And you've heard a lot from the keynote, but we have seen it evolve over many, many months. The first is there's heterogeneity in different kinds of data that they want to treat, but they want to treat it on a single unified platform. Very few people want to have 8,000 specialized databases for specialized things. If you go back 20 years and you can look up on Google things like object databases. There was a time where people said object-oriented databases are going to be a huge market, and they never took off because they required the way you persisted the data to be tied to the object model of the program. But if you then changed it and wanted the same data accessible from another program, it didn't work. So the first thing we see is that having a unified platform for all different shapes of data is super important. Second, providing different access models to it. And third is obviously the things that we see a lot of customers wanting is active-active, because they want to do distribution across regions from an availability point of view, but they also don't want to run purely active-passive anymore, which is if one region goes down, I still have a failover model, and I'm not getting value from the other region I'm running 90% of the time. And then most importantly, until the event happens, I really don't know if the standby is going to work. So all those we think are enormously interesting to our shared customers.
Going back to the database market, looking at it from high level, for years there was one dominant player and 2 others to a lesser extent. How do you see the market 10 years from now? Will it be still dominated by 1 or 2 large companies, or do you see it evolving as more fragmented?
I think there will be new players. I'm not sure it's going to be more fragmented. I think, if you look at all of you sitting here, you're going to use Redis more and more to solve more and more problems, partly because learning how to operate and scale and manage an infrastructure is very hard, right? And so the more problems that can be solved by fewer platforms, I think eventually those platforms win. And so I don't see it being dominated by 1 or 2 players. I think there'll be a bunch of new players, but I don't think it'll be a fragmented market 10 years from now. I think the same thing you saw with structured data 40 years ago, where there was a set of technologies that didn't quite meet the needs, and then relational came along and solved the basic problem that the way I store data should be separated from the way I access it. I think now you're seeing Redis applying a similar model for different kinds of data, broader sets of data than just structured data, but providing that unified access method so that you can see different projections of that same data allows people. How many of you want to learn 18 different databases? Right? That's the core question. And so the winning platform is always going to be the one that makes it easier for people to build applications and manage data in a consistent way. And I think you and your team should be really given a lot of credit. We are extremely proud to be a partner of yours and very grateful that you would be a partner of ours.
Same here, and we are very grateful to you, and we, as planned, we are going to participate in your event very soon.
Yes, we have some really cool announcements next week with Ofer and the team at our event next week.
Finally, you have led large developer communities in the past. what advice would you give the Redis developers here at RedisConf?
I've always found that the smartest developers are the ones who are looking to do the least amount of mundane work. And I don't mean to say that in a facetious way, right? What I mean by that is technology always matures, and once it matures, there's a bunch of very mundane things that just go away because the platform absorbs it. So 5 years ago, if somebody told you you're never going to have to install a computer, connect it to something else with a cable, manage air conditioning for it, find a space called a data center, most people would probably say, are you joking? Today, that's the reality. And so if you were a person who was really focused on learning how to install and configure operating systems, that would probably not be the most useful thing. So my view is data will be the new platform for transformation. And increasingly, people are not going to want to manage database instances, administer them, tune them, all those things. They'll get a serverless platform that provides them data and provides them different ways to access that data. And the more you as developers learn on new ways to use that data, for example, how you can use AI to make predictions on things that are happening, I think that would be far more useful for your careers than learning how to manage compute nodes and block storage nodes and things of that nature. And generally, the higher up you go, the more value you deliver to your own organization and business. And generally, technology moves up the level of abstraction rather than down the level of abstraction through which you access things and learn things.
Thomas, thank you very much. It was very interesting, very inspiring. Thanks for coming and sharing your wisdom with us.
Thank you so much for having me.
So, as you know, Redis is used across many industries, and gaming is one of the most notable industries for Redis. So today we have a panel about gaming, and for this panel, please welcome our gaming panelists, Avram from Scopely, Ishtban from Itermax, and Oren for Redis Labs.
See you guys. Hi. Hi. So it's a pleasure to introduce two of my favorite customers. I have to say it because they are here on stage with me. Esteban.
How are you?
Great. You are the principal SRE in Etomax.
That's right.
And Avram Lyon, head of engineering in Scopely. Maybe you want to take a few seconds to introduce yourselves and your companies. Avram, do you want to start?
Sure. So Scopely is a mobile games publisher, developer based in Los Angeles. And I've been there around 7.5 years now. We have a couple million users, I don't know, some number of million users. And around 6 live games today, most recently Star Trek and Looney Tunes in the past few months. We've been using Redis, actually, and Redis Labs since before you were called Redis Labs. So a long time. And that's us.
Well, I work for Intermodal. I've been there for like 3 or 4 years. And we've developed some famous games like Trivia Crack or Pictionary. And I am the principal SRE, which means I do all kind of cloud-related stuff and resource management. And of course, we've been using Redis for a long time ago, first alone and then with you. So it's good to be here.
Great, thanks. So for me, it's great because I see the backend, I see stuff happening in Redis, but the amazing thing is you guys are running, right, millions of people playing your games, and I just see numbers of latency and transactions. It's pretty cool. So I heard someone tell me recently that if you're in gaming or a gaming company, you either use Redis or you're out of business. Do you think it's true?
So, well, I would say that yes, of course you can solve different problems with different tools, but for us, from our experience, when you are doing a game and you want to succeed, you have to be like prepared to grow and to realization. So when that happens, the less problems you have to solve, better, because you can focus on business and new features. So Redis being that fast, you know, it was really a game changer for us because, you know, it worked fast when you have 10 operations per second. It worked fast when you have 10,000 operations. And it also works fast when you have 10 million operations per second, which was our case. So it's like a different, another issue that you don't have to solve, and it's easy for us.
I'm always the gadfly. I mean, of course not. That's not true. You can make great games with a lot of different technologies. Redis is a great choice. We've been really happy with it in both specialized use cases as well as, I don't know, in many different ways, but you can certainly make a great game that does not touch Redis at all.
That's perfectly fine, yeah. But luckily, or yeah.
And even the best games, I'm sure. Okay, there's no limit.
So in this regard, thanks for your honesty, because I think it's important. It shows that, you know, it's not biased or impartial. Tell me a little bit about how you use Redis. What are the use cases? Because the first use cases that come to mind, I think, for the majority of people, especially if we're talking about gaming, it's caching, it's leaderboards. So how do you use Redis in Scopely or all of your studios or some of your studios?
We started with leaderboards way back at the very beginning. You know, we have had a really wide range of uses. One of our major use cases we actually presented about here at RedisConf a few years ago were more in our data systems, real-time alerting, monitoring, systems built on top of Redis and Hyperlog, which remains our highest throughput use cases for Redis. Most recently, our second most recent game launch is almost entirely in Redis, Star Trek, and they've had some really interesting things they've done around how they've balanced the needs of a persistent world and an MMO with wanting to have stateless application servers. Basically, they're able to do that by offloading so much intermediate state onto a job system in Redis, allowing them to still have stateless scaling on the application layer. It was a really nice pattern. I think it's something that was really Redis certainly made that feasible for them. They're also very much looking forward to the blocking sorted set pop in Redis 5, which.
So how many people are using now Star Trek? It's like millions of downloads within like 5 minutes, right?
It's not millions within 5 minutes. I don't know what the latest public figures are on it. It's definitely a game we're really proud of, and in many metrics, our largest launch so far, and it's found it has a very active user base. Let's put it that way.
Okay. How about you in NetherMax? How do you use Redis? What are the
well, we use it firstly for storing our games and users, but also we've been using it for like a room messaging service. When we developed Pictionary, it has this mode that it was a real-time passing, and at that time streams wasn't available, it wasn't an option, so we go with PubSub, which was an incredibly easy feature to use and which solved a lot of problems. And I remember thinking of the architecture and say, well, someone asked me, what happens if the client disconnects, all the messages will be lost, can he catch up again? And I say, well, no, because PubSub doesn't have that feature, but we think of maybe moving to Kafka if it was necessary, but doing with PubSub allow us to move fast and to have a working solution. And of course, if I had to do it again now, I know that I have streams, so they will be probably the first option to go to.
I see. You also use multiple terabytes of Redis as your persistent storage, right? It's like
yes,
and like using Flash.
Yes, we have more than 6 terabytes of data, and last year we performed this migration, which in case we gave a talk about it, to Redis and Flash. So it was incredible because it allowed us to reduce our infrastructure costs while having this the hotkeys on memory that you always have like a big user base, but an amount of them are playing and the other are like passive users. So it allows us to conserve our database, but also to reduce costs.
Thanks. So Avram, I'm not sure what's the answer here because I'm completely ignorant when it comes to that, but do you capture any data trends across players or characters to make data-informed decisions about future characters' development? And what technology stacks do you use? Redis or not Redis at all, or what other ones?
I think Oren wants to optimize his Star Trek gameplay.
Yeah, exactly.
But we do have a lot of data systems at Scopely, and so a lot within individual game teams. A lot of the data workloads they have, particularly more in the RPG space and MMO space, is about understanding how how users interact with and value the different characters that are available and how they use them. We use Redis in that. I mean, Redis plays a couple of roles in the data ingest and streaming systems. Most of that type of balancing and analysis is done primarily with our batch systems, which are more Spark and S3. So there's not Redis on the ingest, but not on the analysis there.
Yeah. Someone in Redis Labs once said, when you have a hammer, everything looks like a nail. So for us, everything is Redis, but it's great to hear. Like it's very
I'm sure
important.
you would love for our data warehouse to be stored in Redis, but
yeah,
it
of
get
course,
expensive.
Of course. So Avram, you mentioned that you recently launched Star Trek, and I know that you launched also another game that I'm not sure if I want to get my kids to play in it because it's Looney Tunes, but it's very violent on the other hand. So tell us a little bit about the game.
It is not violent, and it's also not for kids. It's 13
Just
plus.
Throwing safes from the on one on each other.
But yeah, we also launched Looney Tunes World of Mayhem in December, and I think one thing, this was a really big deal for Scopely, is that we launched together with Redis Labs 2 major games over the course of 2 weeks. Which our TAM at Redis Labs survived. We all survived, and we're very happy with it. That game also uses Redis intensely, mainly for leaderboards, but also I think a fair amount of, I don't remember already, other use cases as well. I guess what I would say is that having the ability to not have any operational concerns on that major component of our data systems or data systems and applications made it so that our concerns during a critical period, like 2 game launches during the holidays at the end of the year in 2 weeks, we could take that and know that someone else was going to solve that whole part. I mean, as the gentleman from Google was saying, that's the platform you're on top of. We're higher level than that. And so for us, Redis is a magical API that we can use and hit hard until we get a call from Oren saying, "What are you doing?" And I think that that was scary on the surface of it to have 2 major launches in such a small period, but having a solid foundation makes that less worrisome.
Thanks. For me, it really blows my mind because there are a lot of gaming companies out there, and some of them are lucky to have a successful game. And in the case of both of you, you managed to replicate the success, which the odds are, I don't know how to calculate it, are very low, but you still managed to do it. And also for you guys in Etomax, right? You had Trivia Crack, which was like top of the charts for ages and still is, and you recently launched another game.
Yes, we have been like a sequel of the game, Trivia Crack 2, which is having a huge success, and we are going to do another remake of other popular games, and it is easy because when you know some of the, it's very complicated to be successful in different kind of games. You look at other companies doing different games, and sometimes you have to stick with what you know, and we are very successful at doing trivia games, so we are doing this remake that offers different kinds of plays and modes, and using the same Redis base that we have, and of course other kind of technologies to support that.
Great. So before I let you go, I want to use your experience or for doing games for many years. What advice would you give to an aspiring or a new game development company when it comes to making decisions around game architecture design? Yep.
Well, I would say, first of all, avoid accidental complexity. They were talking about a few minutes ago. We are developers, Git people, and sometimes, you have to cross the street, and a developer comes and say, well, I can build you the golden gate, and you can cross the street. But maybe it was not the problem you are trying to solve right now, but you will have it later. So it is hard not to become complex, even with complex problems. And so I will say that you have to go for that path. And for example, when doing microservices, that it's a very buzzword that everybody talks about. I would say that it's not the right choice when you're starting something and you're a small company. You are adding another layer of complexity, and when you need to move fast. So then you have to be aware of the right moment to make the move, but you have to always keep simple. I will say that if you have 2 or 3 solutions possible, the simplest one is the best. And Redis does a good job on that because it's simple, you can understand. And also when you have to go complex, complex solution, it's always good to stick with something that you can understand how it works, because now you will be lost.
Thanks. Avram, do you have anything to add?
My advice in my notes was almost exactly the same. I mean, it's very easy for young teams in particular to get, the romance of it. Oh, it has to be scalable. It has to be fast. I mean, first and foremost, you have to be able to find the experience that unlocks your users' love for the game. And, you really have to ruthlessly optimize for iteration efficiency, which really will mean finding simple solutions. If you have a simple solution and you understand it and you're able to iterate on top of it, you will be able to break through any bottlenecks you encounter. If you try to prevent the bottlenecks, you will encounter bottlenecks you didn't know about and not be able to get through them.
Great. We're out of time. Thank you very much for your time. I hope you enjoyed it, and I'll see you soon.
Okay. Thank you.